Wallace D. Wattles once said that it is essential to have good tools, but it is also essential that the tools should be used in the right way. Good day to everyone. We are Group 4. To start with, may I introduce myself? I am Gladys Megida that will start this presentation and discussion. We will be presenting the different basic measuring and layout tools and the steps in making a layout. Our agenda for today to be discussed are mainly introduction, objectives, basic measuring and layout tools, steps in making a layout, and the overall conclusion for this topic. May I call on Mr. Ebora to discuss the introduction.
Thank you, Miss Gida. Good day, everyone. Join me in exploring the world of precision in workshop practice. Precision, often regarded as the bedrock of all craftsmanship, it is the driving force behind the creation of exceptional works of art, whether it's metalworking, woodworking, or any other form of fabrication. Precision is at the core. And it all comes down to two fundamental elements. First one is the accurate measurements, and the next one is meticulous execution of layout work. In the world of workshop practice, we often associate artistry with the finesse of painter's brush or the graceful movement of a sculptor's hand. However, the true artistry lies in the precise use of tools that provide the foundation for every creation. These tools are often overlooked from their apparent simplicity, are in fact the unsung heroes of precision engineering. They possess the power to transform abstract ideas into tangible realities, ensuring that a piece of metal, wood, or any other material adheres unfailingly to the specifications outlined in blueprints and designs. Now, picture a workshop as a symphony, with each tool serving as a unique instrument in the grand orchestration of this art. From the unassuming scribe delicately etching lines on workpieces to the intricate vernier height gauge orchestrating precise measurements. Each tool plays a vital role in creating a harmony within a well-functioning workshop. This symphony derives its beauty from the skilled orchestration of these tools and measuring instruments, with each contributing its note of accuracy and control to the collective masterpiece. Our exploration today aims to delve deeper into the nuances of these tools and instruments, offering not only definitions but also user friendly, detailed procedures for mastering their usage. Whether you're a seasoned professional with years of experience or a newcomer embarking on the intricate journey of workshop and practice. This guide serves as a valuable compass. It will lead you through the intricacies of these indispensable tools, ensuring that you can harness their full potential. The array of tools and instruments available in the workshop is extensive, ranging from the seemingly simple yet indispensable scriber to advanced digital vernier caliper, with each tool serving as a unique role and purpose. As we journey through this exploration, you'll come to realize how these tools lend their assisting hand across numerous domains, including metalwork, woodworking, and precision engineering. They play a pivotal role in shaping everything from everyday objects to cutting edge innovations, leaving their mark on our world in ways we often overlook. Now, let's discuss the profound significance of mastering the art of using layout tools and measuring instruments. This mastery elevates craftsmanship to a level where every cut, curve, or weld adheres rigorously to the highest standards of quality. This guide aims to impart the knowledge and skills necessary for you to become a proficient in using these tools. It opens the door to the world where precision and excellence are not just aspirations but tangible realities. Beyond merely focusing on individual tool mastery, this guide offers a structured approach to layout work. It maps out a series of steps from the initial preparation to quality control, providing a comprehensive roadmap for various projects. This ensures that precision remains at the heart of every endeavor, delivering not only beauty but also functionality. All in all, precision is the unsung hero of craftsmanship, and the tools of workshop practice are the instruments through which this heroism is achieved. Whether you're a seasoned artisan or a new craftsman, the journey of mastering these tools is a journey towards the realization of precision and excellence. It's about turning dreams into tangible realities. And this guide is your trusty companion on that journey. It brings us to the intersection of art and science, where precision and craftsmanship merge, resulting in creations that stand the test of time and inspire future generations. Thank you for joining me in this journey of exploration where we celebrate the true artistry of workshop and practice. Then, to present the objectives, may I call on Miss Andrinal.
Objectives. This guide to familiarize reader with various layout tools and measuring instrument used in workshop practice. It provides clear definition and description of each tools, enabling proficient use. The guide emphasizes precision and accuracy, covering various industries and projects. It also provides a structured approach to layouting, covering, preparation, machine, and quality control. The goal is to empower individuals with the knowledge and skills needed for precise measurement and markings.
Thank you, Crystalline. Now, in the world of precision work, having the right tools is essential. Today, we'll explore basic measuring and layout tools that are indispensable for a wide range of tasks. Starting with a scriber, a layout tool used to produce fine and accurate lines on work pieces. To use a scriber, you have to hold it like a pen with a firm grip. Place the point of the scriber at the starting point of the line you want to scribe. Apply gentle downward pressure while pulling the scriber towards you. Keep the scriber steady and maintain a consistent pressure to create a fine and precise line on the workpiece. A divider, a tool for laying out circles, arcs, and radii, also used for measuring distances. Adjust the distance between the two legs of the divider to match the desired radius or distance. Place one leg of the divider at the starting point where you want to create the circle or mark a distance. Rotate the other leg to scribe the desired arc or mark the endpoint accurately. A trammel, a layout tool used that can scribe larger distances with the use of extension rods. Attach the necessary extension rods to the trammel points to reach the required distances. Place one trammel point at the starting point and the other at the end point. Maintain stability and accuracy while scribing by moving the trammel along the workpiece. A hermaphrodite caliper, a tool used for laying out lines parallel to the edges of a workpiece. Place one leg of the hermaphrodite caliper along the edge of the workpiece. Adjust the other leg to the desired distance parallel to the edge. Ensure the hermaphrodite caliper remains parallel to the edge while scribing the line. A surface plate provides a true and smooth plane surface for accurate measurements. Ensure the surface plate is clean and free of debris. Place the workpiece or measuring instrument on the surface plate. Utilize the surface plate as a level and stable base for taking precise measurements with other instruments such as height gauges and surface gauges. A vernier height gauge, a caliper with a special foot block for use on a surface plate. Lower the gouge gently onto the workpiece while keeping it perpendicular on the surface plate. Carefully note and record the measurement from the vernier and main scales. A surface gouge, used for layout work, especially for scribing lines parallel to the surface. Place the surface gouge on the work surface. Adjust the scriber to the desired distance from the work surface. Ensure the surface gauge remains stable and parallel to the work surface while scribing out lines. A bevel protractor consists of an adjustable blade with a graduated dial for measuring angles. Position the bevel protractor's blade against the reference surface or workpiece. Adjust the blade's angle by rotating it, and carefully read and record the angle measurement from the graduated dial. A combination square set, a versatile tool for various layout operations including linear measurements, right angles, and angles. Select the appropriate component of the combination square set, a blade, a square head, a protractor, or a center head, based on the specific layout or measurement task. Ensure the chosen component is securely attached to the square set stock. Use the combination square set component as needed for accurate layout and measurement. A steel scale, a linear measuring instrument with divisions in both centimeters and inches. Place the steel scale along the object or distance to be measured. Align the 0 point of the scale with the starting point of the measurement. Carefully read the measurement at the end point of the object or distance using the appropriate units, either centimeters or inches. A vernier caliper, a widely used linear measurement instrument with a least count of 0.02 mm. Open the jaws of the vernier caliper and place it around the object to be measured. Gradually close the jaws until they are in light contact with the object. Read the measurement from both the vernier scale and the main scale, ensuring alignment of the zero marks. Check the outside diameter or circles with high accuracy as much as 0.01 millimeters or less. Open the micrometer and place the object to be measured between an anvil and the spindle. Gradually close the micrometer by turning the thimble until it gently contacts the object. Read the measurement from the main scale and the vernier scale. A vernier depth gauge, used to measure the depth from the surface of reference of an object. Position the vernier depth gauge's base on the reference surface. Lower the gauge's rod until it contacts the bottom of the cavity or object to be measured. Read the measurement from the vernier and main scales. Vernier bevel protractor, an angular measuring instrument with a least count of 5 inches. Place the vernier bevel protractor on the workpiece or reference surface. Adjust the angle by moving sliding to the desired position. Read and record the angle measurement from the protractor's dial, considering both degrees and minutes. Dial indicator, a plunger dial gauge. It is used to compare workpieces against a master with precision. Secure the dial indicator to a stable base or fixture. Position the plunger or contact point of the dial indicator on the workpiece's surface to be measured. Observe and record the variation or runout indicated on the dial. A lever dial gauge or a test indicator measures sensitive contact with a range up to 0.80 mm. Attach the lever dial gauge to a fixture or stand, ensuring it is securely mounted. Position the contact point of the gauge on the area to be measured. Observe and record the duplication or reading on the gauge's dial, which provides a precise measurement of the contact or point's movement. Engineering square ensures accurate and straight lines when drawing or marking. Position one leg of the engineering square firmly against the workpiece's edges. Draw a straight line along the other leg, using it as a guide for precision. A V-block, used for precise marking and holding of objects in metalworking. Place the workpiece into the V-block, ensuring it sits securely. Use clamps or fixtures to hold workpiece firmly in place, allowing for accurate marking and machining. Now, to discuss the next set of basic measuring and layout tools, here is Michelle.
Thank you, Miss Rina Taylor-Sia. I am Michelle Ete, here to celebrate further on different basic measuring and layouting tools. Now, we move on to another tool, radius gauge. It is a tool used to measure the radius of objects. Procedures. Select the appropriate gauge, then place it against the curved part. Verify the alignment with the object's contour and record the radius. The second one is the digital vernier caliper. It is an upgraded version of the analog caliper with digital readout 0.01 millimeters. First, place it around the object to be measured. Then close the jaws until contact. Lastly, read the precise digital measurement. Here we have the inside micrometer. It measures the larger internal dimensions of holes and registers. Open the jaws, place the measuring rods into the hole or bore. Close the micrometer until contact and read the measurement. The depth micrometer. It measures depth with precision and accuracy. Please count of 0.01 millimeters. First, position the base on the reference surface. Lower the spindle into the activity. Then read the measurement from the scales. The next tool is the measuring tape, an instrument used to measure longer distances. First, extend it along the object to be measured. Keep it taut and straight. Then read the measurement from the tape. Here we have the spirit level. It is a tool used to check the level of surfaces. Place it on the surface to be checked. Adjust it until the bubble is centered between reference lines for a level reading. Next is the feeler gauge. It measures the clearance between two parallel flat faces. First, we select the appropriate blade. Insert it between parallel surfaces. Then gradually increase thickness until it fits snugly. Snap gauge. A go and no-go gauge for checking dimensions within tolerance. Use the go gauge to check dimensions with tolerance. If it passes go but not no-go, it meets the tolerance. Flag gauge or the fin gauge is used for assessing hole or object diameters and for collaboration. Insert the gauge to check hole or object diameter. It should fit smoothly if the size is correct. These are basic measuring tools for linear measurements. Place the point at the starting point of the line. There are different types of steel rules. One is standard steel rule, flexible steel rule, narrow rule, hook rule, shrink rule, short rule, slide caliper rule. Next is the rule depth gauge, a tool designed to measure the depth of small holes and slots. Consists of a steel head with a slot for a narrow rule. Measure the depth of small holes and slots. Outside calipers, tools use measure outside diameters. First, measure outside diameters. Then to measure hole diameters, open the appropriate size, hold against the hole wall, and adjust it until it touches the opposite side. The inside calipers are calipers widely used for measuring and checking bearing clearances, adjusting tappets, spark plug cups, jig and fixture parts. Measure inside diameters and slot widths. Adjust the approximate size and feel for proper contact. The thickness gauge, another basic measuring tool for determining the pitch or number of threads inch on a threaded part or in a top hole. Place it around the object to be measured. Close the jaws until contact. Read the precise digital measurement. Screw pitch gauge, an instrumental used in determining the pitch or number of threads each on a threaded part or in a tuft hole. First, select the closest match the thread you want to measure. Then, align the selected blade into the thread. Make sure there's no gap between blade and the thread. Lastly, record the pitch volume mark on the selected blade. Next is the angle plate. Precision tools made of iron, tool steel, or granite. Ensure it's clean and defrost free. Then position the workpiece on the angle plate. The universal precision gauge tool is used for setting cutting tools on shapers, planners, measuring transferring, scribing, and height gauge. Select the specific application to be used. Adjust the gauge to the required settings. Lastly, we have the straight edge tool used for drawing straight lines and inspecting surfaces for straightness and flatness. Ensure it's clean and defrost-free. Place the steel straight edge on the surface to be inspected. Here is Miss Gladys May Gida on steps in making a layout.
Thank you, Miss Ate and Miss Garcia. Steps in making a layout. Laying out work means accurately inscribing clean, sharp lines on the blank workpiece to show center lines, shape, or form of the finished workpiece, locations of centers for holes, circles for hole sizes, angles, arcs or curves, and slants. Dimensions for the lines to be inscribed on the metal are taken from the blueprint or sketch of the part to be made. Here are the proper steps in making a layout. First, preparation. Start by ensuring that your workspace is clean, organized, and well lit. Gather all the necessary layout tools and instruments, including scribers, dividers, calipers, combination sets, punches, surface gauges, and any precision tools needed for the job. Put on appropriate safety gear such as safety glasses and roll up your sleeves to prevent accidents. Second, surface preparation. Clean the workpiece surface that you intend to lay out on. Remove any dirt, grease, or debris. Apply a thin, even coat of layout dye to create a dark background, making layout marks more visible. Third, reference points. Begin by setting up reference points on the workpiece. Ensure that one end is squared or machined flat. This will serve as your reference point for measurements. Fourth, blueprint analysis. Carefully examine the engineering blueprint or drawing that specifies the dimensions and layout details for the workpiece. Understand the scale used in the blueprint. It may be to scale, larger or smaller than the actual size of the workpiece. Fifth, semi-precision or precision classification. Determine whether the layout work needs to be semi-precision or precision based on the required accuracy. Precision layouts require specialized tools and greater accuracy. 6. Marking dimensions and features. Semi-precision layout. Use tools like dividers, calipers, and combination sets to mark dimensions, lines, holes, and arcs on the workpiece, following the blueprint. Prick punches, center punches, or automatic center punches are used to create small indentations or marks at the points to be drilled, cut, or machined. For curves or arcs, set the dividers to the desired radius and carefully scribe the arc. Notches and angles are marked similarly using appropriate layout tools. 7. Precision layout if required. If precision layout is needed, employ specialized tools, like vernier height gauges, dial tests. Ensure that the workpiece is precisely aligned and marked to meet the tight tolerances specified in the blueprint. 8. Verification and inspection. After completing the layout, perform a thorough inspection to confirm that all dimensions and features are accurately marked. Use measuring instruments like micrometers, calipers, and gauge blocks to double check critical measurements for precision layouts. Ninth, documentation. Document the layout work, which may include noting down measurements, reference points, and any specific instructions provided in the blueprint. 10th, clean up. Clean the workpiece to remove any layout dye or marks that are no longer needed. Return all layout tools and instruments to their designated storage locations. 11. Machining. The final step is to proceed with the machining process based on the layout marks and dimensions. Ensure that the machining operations are carried out with precision and accuracy, aligning with the layout work. 12. Quality control. After machining, perform quality control checks to ensure that the final product meets the specified tolerances and requirements. These steps outline the process of layouting from preparing the workspace to carrying out precision layout work and ultimately machining the workpiece to the required specifications. Lastly, to present the conclusion, may I call on Miss Endrinal.
Conclusion. Measurement and layout tools are crucial for successful DIY, woodworking, and building projects. They ensure precision, consistency, and effectiveness, and are essential for various dimensions and angles. Investing in high-quality tools reduces material waste and improves the aesthetic appeal of a project. Skilled craftsmen can master these tools through practice and expertise. These tools are essential for safety, high quality, workmanship, and efficient project execution. To ensure continued precision and dependability, it is recommended to invest on top high quality instrument, routine maintenance, and calibration.
This ends our presentation about basic measuring tools and layout tools and its steps in making a layout. Let me end this presentation with a quote from Lily Waters. The success of your presentation will be judged not by the knowledge you send, but by what the listeners receives. May you gain knowledge from our presentation and may you use it the right way. Thank you and God bless us all.